language of hypothesis testing. Here on this board we have a friend of yours wants to play a simple coin flipping game. If the coin comes up head, you win. If it comes up tail, your friend wins. Suppose outcome of 5 plays of the game is, here we have, all these are tail. So the question is your friend cheating? So we want to find the probability of having 5 tails in a row. This is equal to probability of tail and tail. So we have 5 tails here. So this one is equal to, if you remember, we have for coin, you can have head or tail, but the probability for each one is 1/2. Meaning that probability of tail is 1/2. In between we have and, so multiply. Multiply this by itself 5 times. You can write this way or use power. The power is 5. So 2 to the 5th power is 32. And this one is equal to 0.03125. Okay, so this is what we have. Now I want to interpret what that means. So here we have the probability is only about 3 out of 100. So this is about 3 out of 100, because that is about 3%. So the question is, will we get 5 tails in a row? So on this part, the question is that, is your friend cheating, or did you just happen experience an unusual result from a fair coin? So this is at the heart of hypothesis testing. So for this part, we're going to use hypothesis testing. We're going to make assumption about reality, and then look at sample evidence to determine whether it contradicts our assumption. So we're going to make assumption, and then we're going to have sample evidence. Okay. Determine the null and alternative hypothesis. Hypothesis statement regarding characteristics of one or more populations. So here we have these statements. We will work on this and the examples that we're going to cover here in this section. So the first one, in 2008, we have 62%. Here is 62% of American adults volunteered their time for charity work. Okay, what I have here is 62%. And here, according to a study published, here we have mean is 3.25. And the third one, what we have is standard deviation. So standard deviation is 0.23. So we have these three. And this one was p hat. Okay, so this one was sample proportion. Here we have mean. Can I write it up for here? The sample proportion on the first one is equal to 62%. Here for second part, mean is 3.25, and here standard deviation is equal to 0.23. So we're gonna test the types of statements using sample data because it is usually impossible to have access to the entire population. So if population data are available, that means that there's no need for inferential statistics. So what is this one is hypothesis testing as procedure based on sample evidence. So this is based on sample evidence and probability used to test statements regarding characteristics of one or more populations. Okay, so here I want to have the other words for hypothesis test. So hypothesis tests are used to test the validity of a claim that is made about population. So the claim is called null hypothesis. And we're going to show this with edge. Here is 0, but we call it edge not. And this where we have null hypothesis, and just as alternative. So for null hypothesis, we're going to use this edge not, and for alternative, we have edge 1. So what that edge not is a statement to be tested, and null hypothesis is a statement of no change, no effect, or no difference, and is assumed true. So it's assumed true until evidence indicates otherwise. Now what is this one? Alternative hypothesis, a statement that we are trying to find evidence to support. Okay. What we have here is in this chapter, so there are 3 ways to set up the null and alternative. The first one here we have equal hypothesis versus not equal hypothesis. So we call that two-tailed test. The first one here is null hypothesis, and this is alternative. For the first one that we have for null, we always have equal to. On left side, we're going to have parameter, so some parameter equal to some value on right side. Depending on what you have here on left, we're going to work on examples. So you may have mean, or standard deviation, or whatever is given. Now here, second part, we have left tail test. Since we have left tail, here we have less than for alternative. The third one, so for all of these, just remember that for all of these on the first part, null is equal to. It's not changing. And here, third one, we have right tail. Since we have right tail, here we have greater than for alternative. So as I said, for all of these, for null hypothesis, we have equality. So I have that for here. Edge not is always written same as statement of equality. And for these two, since we have the first one is here we have left tail, here is right tail, meaning that we have one tail test. So this one on top is two tail. With these two, each one of these two, we have one tail test. So in this part here again, I have exactly what I covered here on top, that what null and alternative is. So once again, null statement to be tested, and this is always true, and we have statement of equality. So this is true until evidence indicates otherwise. And we're trying to find evidence that support this statement in the alternative hypothesis. So same thing as exactly same as what we have here, a statement that we are trying to find evidence to support. But this is in other words, nothing new. Example, for each of the following claims determine the null and alternative hypothesis, state whether the test has true tail, left tail, or right tail. These are exactly what we had in the first page. So the first one, part A. In 2008, we have 62% of American adults. So we have this number. The 62% is, obviously this is proportion because we have 62 divided by 100. So what our parameter is P, because we have proportion here. Okay, and researcher believes that this percentage is different today. So it's saying that this is different today. What means that we don't have any information about having greater than or less than. Says that different, meaning that is not equal to. So we're going to use that one. Okay, so once again, we're going to use is not equal to in here, or proportion. We have proportion, we're going to use P for parameter here is. So that P doesn't stand up for parameter. Here we have this parameter. We may have proportion, mean, standard deviation, depends on what is given. So here we have null. Here is alternative. So H0, H1. Here is P. On top, for null, we always have equal to, and that is equal to 62%. And here we have is not equal to 62%. And it's asking if this one is true tail, left tail, right tail. Since we have is not equal to, this is true tail. According to the study published in March 2006, the mean, so here is mean, and that is equal to 3.25. And this part, the researcher believes mean length of call has increased. Okay, here we have increase, and we're gonna have greater than for alternative. Since we have greater, this means for this part we have right tail test. So this is right tail test. Now in this part we have null, alternative, H0, H1. Here we have mean. So for the first one we have equal to 3.25. And here is, we have greater. So mean is greater than 3.25. Now part C, using an old manufacturing process standard deviation. So here we have standard deviation, and that is 0.23. And manager believes the standard deviation has decreased. So here we have decreased. On this part, we have less than. And this is left of test. Now null alternative. Here we have standard deviation, and that is equal to 0.23, and this one we have less than 0.23. Now this part explains type 1 and type 2 errors. Here we have 4 outcomes from hypothesis testing. We have all these. As the first one, reject null hypothesis, or rejecting this null hypothesis when its alternative, so when alternative H1 is true. Based on that, this decision would be correct. So if we have that one, that means that decision is correct. We have exactly same thing here on this part. So H naught, rejecting it, is this part. And here we have H1. So H1 is true. So based on this and that one, we have correct conclusion. The number 2, do not reject null. When the null hypothesis is true, obviously we shouldn't reject something that is true. Again, this decision would be correct. Here we have do not reject when null is true. So this is what we have, correct conclusion. And third one, now reject null hypothesis. So rejecting H naught when the null hypothesis is true. So this is obviously not correct because we shouldn't reject something that is true. So, but here rejecting this null when that is true. So this one is type 1 error because this one is not correct. We have rejecting null. We have this one when null is true. So based on these two, we have type 1 error. Now number 4, do not reject. So do not reject null when the alternative, so when alternative is true. Okay, so this probably have do not reject null when alternative is true. So based on this row in this column, we have type 2 error. So that is also not correct. Here is an example for type 1 and type 2 errors. So the idea of type 1 and type 2 errors by looking at the hypothesis testing from a point of view of criminal trial. Here, null, the defendant is innocent, and alternative defendant is guilty. So type 1 error is like putting an innocent person in jail. And here, type 2 error is like letting guilty person go free. for type 1. So we should have kept H0, because we shouldn't reject something that is true, because type 1 was rejecting null when null is true. And type 2 should have rejected H0, because here we had do not reject null when alternative is true. So when alternative is true, that means that we have to reject null. Example for each of the following claims. Explain what it would mean to make a type 1 error. What would it mean to make type 2 error? Part A. These are exactly what we have on the first and second page. So we have 62%, and this part we had proportion. So this is 62 divided by 100, so this is proportion, and that is equal to 0.62. So for type 1, error would be if the researcher concluded P is not equal to 62%, then the true proportion is P equal to 62%. When null hypothesis is true, meaning that the true statement is, or proportion is equal to 62%. But we concluding that is not. So this is type 1. The error is so this is what we have for null and alternative. The type 1 is when we have this part true, when we have null hypothesis true, but we rejecting it and concluding that this alternative is true, but it's not. So when you have this part true, you should accept that one. So this is type 1 error. And now type 2. So for type 2, we have do not reject null hypothesis when alternative is true. So for this part, error would be if the researcher fails to reject null, but actually the percentage is not equal to 62%, but it is so meaning that we have alternative true, so that we're not rejecting null. So error would be if the researcher fails to reject null, then actually the percentage is not equal to 62%, or in other words, P is not equal to 62, and this is alternative. This one is mean, here is 3.25, and this part was increasing, so researcher believes that mean length of call has increased. So what type 1 is? Error would be if researcher concludes that mean is greater than 3.25 and the calling is still 3.25. So when it's actually 3.25, it's claiming that it's greater than 3.5. So rejecting null but accepting alternative. Okay, so this was type 1 error. We rejecting this null when this is true. And type 2 error is not rejecting this null when alternative is true. So error would be if the researcher fails to reject null, then actually mean is greater than 3.25, so when actually this alternative is true. Okay, so here's what we have in words. Error would be if the researcher fails to reject null when actually the mean is greater than 3.25, or in other words, this alternative is true. State conclusion to hypothesis test. If you have noticed, we on the previous part we didn't use accept, null hypothesis. Instead, we use reject, do not reject. So without case that is because without having access to entire population, we do not know the exact value of parameter stated in null hypothesis. So rather, we say that we do not reject null hypothesis. This is just like the court system. We never declare defendant innocent, but rather we say the defendant is not guilty. So instead of using this innocent, we use not guilty. So sample evidence can never prove the null hypothesis to be true, but not rejecting null hypothesis. We are saying that the evidence indicates the null hypothesis could be true. And that there is not enough evidence to reject our assumption that null hypothesis is true. Here is an example. So again, we have this one. We have mean as 3.25. And here is increased. Part A, suppose samples evidence indicates that the null hypothesis should be rejected. Here it says this one should be rejected. State the wording of the conclusion. Yeah, we're writing what we have for H0 and H1. Here we have mean equal to 3.25, and this one mean is greater than 3.25. This part's given that our null hypothesis should be rejected. We only need to write this in words. So what that means that there is sufficient evidence to conclude that mean on a phone call on a cell phone is greater than. So when we rejecting this null hypothesis, that means that alternative is true. So this part is true. So mean is greater than 3.25. So on this part we reject null hypothesis. Now part B. So sample evidence indicates that a null hypothesis should not, this part should not be rejected. Say this in words. What that means is we have should not be rejected. There is not sufficient evidence to conclude that a mean is greater than 3.25, but is equal to 3.25. Just keep in mind that since we have should not be rejected, here we have there is not sufficient evidence. And on the previous part, here should be rejected, and this one is there is sufficient evidence. On the part A we have reject, here do not reject. This is already given.